Part 2. Transformations of sinusoidal functions. The general formula for any function is given as y equals a f of b x minus c plus d, where a is the vertical stretch, absolute value of a, is the vertical stretch, but it's called the amplitude for trig functions. 1 over b is the horizontal stretch, or again for trig functions, enables finding of the period using the formula p equals 2 pi over b for sine-cosine functions, and p equals pi over b for tangent functions. Again, remember that if you are in degrees, 2 pi is 360 and pi is 180. C is the horizontal translation, or the phase shift for trigonometric functions, and D is the vertical translation, or vertical displacement, median, or midline for trig functions. If a is less than 0, then the graph gets reflected over the x-axis, or vertical reflection, and if b is less than 0, or negative, the graph is reflected about the y-axis, or horizontal reflection. If c is less than 0, the graph translates c units left. So again, if c is negative, it's left, and if c is positive or greater than 0, it translates to the right. If d is negative, it translates down, and if d is positive, the graph translates up. Transformations of trig functions are basically treated the same way as before, but their periodic nature requires a little additional thought. Okay, so I'm going to give you an example here. We're going to sketch the graph of the function y equals 5 sine of 0.5 theta plus pi over 2 plus 3. Showing at least 2 complete cycles, we're going to describe the transformations and state the domain and range. Okay, so let's start with our transformations. So we have a vertical stretch by a factor of 5. Okay, we have a horizontal stretch by a factor of 2. Because remember, it's 0.5 is 1/2, but you take the reciprocal of it for your b value. To get your horizontal stretch. We have a horizontal translation by pi over 2 to the left, and a vertical translation by 3 up. Okay, good. Now, for a sine function, the domain, of course, still is real numbers, and the range is the distance between the max and the min. So, in this case, our max is going to be, max will equal the amplitude plus the d value, so that's going to be 8, and our min will be the d value minus the amplitude, because in the maximum we have the midline, or median, plus however high above it goes, okay? And then for the min, it's the midline minus however low it goes. So that would become 5 take away 3, 3 take away 5. 3 subtract 5 gives us -2. So my range is between -2 and +8. And again, it's going to be a solid line, so that our curve, y belongs to reals also. Okay, great. Now let's get working on graphing this up. Okay, so our original point starts at 0, 0. We know that it's going to be stretched horizontally and vertically, but that does not affect 0. So it's going to get translated by pi over 2 to the left and 3 up. So I'm going to make every individual line a pi over 2 and up 3. So that's where that's going to start. I'll throw some labels on this graph here so it's easier for you to follow along. So that's pi, and that would be 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and we'll go to 8 pi. And of course this would just be over here, would be -pi. And on the y-axis, each one is worth 1. So that's 4, 5, 6, 7, there's 8, and 2, 3, -4 down there at the bottom. Okay, and if we have a horizontal stretch by a factor of 2, then we have a new period. So period is equal to 2 pi over b. Our b value was 0.5, or half, so 2 pi divided by half flip and multiply, that gives you 4 pi. So our period is 4 pi, and of course we want 2 cycles, so I need at least 8 pi. Okay, let's plot some more points on here. All right, so our previous maximum was at pi over 2, but that gets times by 2, so that becomes pi. And then it gets translated back pi over 2 to the left, so that puts us back at pi over 2, okay? And of course the maximum, it's been times 1 times 5, because the original amplitude of sine is 1. 1 times 5 is 5, plus 3 more makes 8. So that's at 1 and 8, okay? Good. Then, if you think about this line here as being our median, I'll put that in green. Okay, our median is at 3. Okay, good. That's where our former x-intercepts are now going to cross. So, because everything gets moved over pi over 2 to the left and 3 up. So, we have another point here at 3 pi over 2 on the x-axis, because the previous one was at pi. Previous x-intercept was at pi, and then of course we times that by 2, so we get 2 pi, and then move it pi over 2 to the left, so that puts us at 3 pi over 2. Okay, and then if you'll notice, we have an important point every 2 blocks. So the next one is going to be over 2 blocks and down our amplitude, which is 5. So that should go here. Good, and over another 2 blocks and up, and over another 2 blocks and up 5, and over another 2 blocks and down 5, over another 2 and down 5, over another 2 and up 5. Okay, great. There is our new curve. And we'll connect the dots with a nice smooth curve. Oh, no, that one doesn't turn out too bad, actually. Okay, awesome. So there is our graph. All right, a couple more examples on this section. Okay, write an equation in each of the forms y equals a sine b and y equals a cos of the b x minus c plus d for the given graph. Okay, so what we need to do then is figure out what a, b, c, and d are. All right, so let's start with a. A is equal to max minus min divided by 2. My maximum y value is at negative 0.5 minus my minimum is at negative 1.5 divided by 2. So plus plus, that becomes 1 divided by 2, so my amplitude is 0.5. My d value is similar, but max plus min divided by 2. So that's negative 0.5 plus negative 1.5 over 2. So that puts me at negative 2 over 2, which is negative 1. Okay, good. Next we'll find the d value. Whoops. Sorry about that. We'll find our b value. All right. So, if we find the period, remember from max to max is the period, or from max to min would be half the period. So the distance from max to min would be 2.62 divide or subtract 1.57 times by 2. Okay, so that gives us roughly a value of 2 pi over 3. Okay, and so because 2 pi over 6 or 2.62 minus 1.57 gives us a pi over 3, and then if you times that by 2, you get 2 pi over 3 using a decimal approximations. Okay, so period of course is 2 pi over b, so that becomes 2 pi over 2 pi over 3, so that just becomes 3 because the 2 pi's cancel out when you flip and multiply. All right, and as far as shifting goes, For the cosine graph, remember it starts on the midline and on the y-axis. So this graph does that, but if you notice this graph starts there and goes downward instead of going up. So that's just a vertical reflection in sine. So there's not going to be any c value for sine. We're just going to reflect it. Okay, and for cosine, it starts normally on the positive at positive 1, but of course this guy got shifted over to 1.57, which is a positive pi. Okay, so we can also shift it back this way. So if this is a pi over 2, then the other direction to make up the 2 pi over 3 would have to be a pi over 6 to the left. We always try to make sure that our horizontal shifts are the closest amount to the y-axis. So my c for cos will be pi over 6 to the left. Okay, so let's fill in our formulas. So y equals a, which was 0.5. Remember, for sine, we were making that a negative because we wanted to reflect it. Sine of b, which is 3 times x, because there was no horizontal shift, minus 1. Okay? Good. We can also write that if we did want to take it and shift it to the right, that's a shift of pi over 3. So I could also write this as y is equal to 0.5 sine of 3 times x minus pi over 3 minus 1. In terms of cosine, same a's and c's or a's and b's and d values. The only thing here that's going to change is our c. Okay, so that's cos of 3 times x plus, because we're going to the left, it's backwards, minus 1. Okay, how can you check this work? Well, you can feel free to take out your graphing calculator and graph all 3 of those functions and see if they go through the points indicated on this graph. Last example. Write the equation of each cosine function in the form given, its characteristics. So amplitude of 2, period is pi, phase shift pi over 3 to the left, and vertical displacement of 1 unit down. Okay, so first thing we need to do, if the period is equal to pi, then we want to go 2 pi over b. So b would of course equal 2 pi over p, the reciprocal. So that's 2 pi over pi, which just equals 2 because the pi's cancel out. So my equation would read y equals, my amplitude is 2, cos, b is 2, bracket, x minus c, so we have pi over 3 to the left, so that becomes x plus pi over 3, because minus minus becomes a positive, and plus d is minus 1 for going down 1. Okay, part B, amplitude of 1/4, period of 540 degrees, phase shift of 60 to the right, and a vertical displacement 2 up. Alright, so again, we're going to use b equals, instead of using 2 pi, we're going to use 360. So 360 divided by p, so that's 360 divided by 540, which is equal to 2 over 3. Okay, so y equals, the amplitude is 1/4, cos, my b value is 2/3, my phase shift is 60 degrees to the right, so that's x minus 60, and my displacement is 2 units up, so that's plus 2. Okay, good. Lots of practice there on page 250. Show your teacher when you're finished, and then you'll be ready to start on part 3.